Assalamualaikum Nahai. My name is Muhammad Ikrar Alimi bin Muhammad Isha. I am with Beckham Achopol.
Salam sejahtera. My name is Beckham Achupal from PAS0071B2, and I will be presenting about Chapter 2 and Chapter 4.
And today we are presenting about carbon, a unique element. These contents of the presentation are mostly about the chapters that we have learned during CHM083, and we are be relating these 4 chapters to carbon, specifically carbon. These are the objectives that we are be adding today. Let's get started. First chapter is structure of an atom. Atom is the basic unit of an element. The atoms usually have electrons, protons, and neutrons. And protons and neutrons can combine into a nucleus, which is represented by this symbol and circle here of carbon. The next one are subshells. In this case, carbon has 2 subshells. The first subshell can only have 2 electrons, meanwhile the second subshell can have up to 8 electrons, but in this case carbon has 4. So in total carbon has 6 electrons. The next one is electronic arrangement, which is another form of structure of atoms. The first electronic arrangement is dartboard. This is similar to atomic structure or atomic model. The next is orbital diagram. This is the one where the arrows goes upward and downwards. In this case, carbon has 6 arrows. The next one is SPDF notation. These are basically whole numbers, letter, and a superscript. And superscript basically, yeah. They are so in this case, the carbon has 1s2, 2s2, and 2p2. In order to find the electrons, you have to look at the superscript, which is the small number 2, 2, and 2.
This is Chapter 2, which is talking about the periodic table. So in the periodic table, there is classification. Basically, there is a way to identify the elements in the table, which is said here, where elements are metals, non-metals, halogens, and noble gases, based on where they are in the periodic table. Here, carbon is classified as a non-metal that does not have metallic properties. So one of the ways to find out or class the element is through their groups and their periods, which finding out to their groups is the vertical lines or periods from their horizontal lines in the periodic table. And so how we found out that carbon is a non-metal is based on where it's placed, which is group 14 and at period 2. So for the properties of carbon, carbon is a non-metal, which means that carbon can easily gain electrons. It is poor at conducting heat and electricity, is a brittle, good oxidizing agent, form acidic oxides, have 4 to 8 electrons in their outer shells.
So the next chapter is chapter 3, which is chemical bond. There are various types of chemical bond. First one is ionic bond, covalent bond, and metallic bond. Ionic bond consists of a metal that has bonded with a non-metal, halogen, or noble gas. And the next one is covalent bond, which is a non-metal, halogen, or noble gas that have bonded with non-metal, halogen, and noble gas. And the final one is metallic bond. Metallic bond consists of a metal bonded with a metal. In this case, carbon can only be in an ionic bond and covalent bond, but not metallic bond. And the next step is Lewis structure. This is carbon Lewis structure. There are 4 dots here that represents valence electron on the outer shells. Only the outer shells, basically the last subshells that we have seen in an atomic model and such. And the letter represents the element. The next one is an example of ionic and covalent bond of carbon using Lewis structure. This image, I have drawn it. As you can see here, we have calcium and carbon. So calcium has 2 valence electrons, and it is going to donate the 2 electrons to carbon. Carbon has 4 valence electrons, um, but it's not enough to make it stable. So there are 2 carbon instead. In total, there are 8 electrons they have received, which is 10. And so calcium carbide was made. The next is covalent bond. Covalent bond, basically 2 elements share the electrons. In this case, carbon has bonded with another carbon. As you can see, there are actually 4, but they share 2. This double line basically means double bond, thus creating C2.
Here we have chapter 4, which is called mole concept. What we learned in mole concept is shown on this slide here, which is relative atomic mass, which is the ratio of the average mass of atoms of a chemical element in a given sample to the atomic mass constant, which is also known as molar mass. Next up, we also learn about mole, which is the standard scientific unit for measuring large quantities of very small entities such as atoms, molecules, or other specified particles, and mass is the unit for amount of matter. So to find these, we have the Avogadro's number, which is a constant in finding the number of moles in a mole. Constant meaning that it is a fixed number and it will always be there when trying to find it. So the few formulas that come up for this is for finding mole is mass over molar mass, and to find the number of molecules is the mole times with Avogadro's number. The next thing we learn in chapter 4 is empirical formula, which is the ratio of a compound of 2 elements. The ratio is determined when both elements mass were divided by molar mass. Later then, the biggest mole of one of the elements is divided by the smallest mole of the other element. The mole ratio is the ratio for the empirical formula, for it has to be multiplied until it is its simplified form and not in improper fractions. For example, that's shown down here, carbon dioxide, which, as you can see, after all the calculations, it becomes CO2. Next up, we have molecular formula, which is basically the multiplication of an empirical formula. So in order to get the molecular formula, N must be determined as it multiplies the empirical formula. So the formula is N equals to molar mass over empirical formula molar mass. For the example shown here, N equals to 88 grams of mole of CO2. And we use the molecular formula and we get the answer. So that is all from us. Hope that the presentation was informative to you, and thank you for your time.